We've already looked at the addition rule for disjoint events. In a lot of situations, though, you'll be working with two events that are not disjoint, and we need a more general rule that would apply to that situation. And this is how we're going to get it. Let's look at the example we've been working on in several videos now. Sample space is the numbers 1 through 10, and we're going to select a number at random. The event that we draw a prime number contains 2, 3, 5, and 7 as outcomes, and the probability of that event A is 0.4. Event B is that we draw an even number, and the outcomes in that event are 2, 4, 6, 8, and 10, and the probability of that event B is 0.5. Here's a Venn diagram that illustrates that situation. You see that we have the A circle and the B circle, and inside these two circles we have this overlap, A and B, and 2 is the only outcome that is in that little lens-shaped piece, because that's the only even number that is also prime. And then we have the other prime numbers out here in A, the other even numbers out here in B, and then 1 and 9 are neither even nor prime. Okay, the probability of A or B in this situation is 0.8. We have 8 outcomes inside the union of A or B, and that's not equal to the probability of A plus the probability of B, as it would be if the events were disjoint. Those two add up to 0.9, and it's not equal to 0.8. And the reason for this is that this area in the middle, this A and B, is getting counted twice when we do this little summation right here. If you add up those two probabilities, you're counting the probability of A and B twice. And since in this situation, if A and B are not disjoint, that probability is not 0, you're double counting something. And in order to correct for that double counting, we have to subtract the probability of A and B once. And so this gives us the general addition rule. For any two events A and B, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Let's look at some examples that illustrate this. Okay, we're going to find the missing probability in each of these situations. So we have probability of A is 0.7, probability of B is 0.4, probability of A and B is 0.3, and we want to find the probability of A or B. Well, this addition rule is ideally set up for this particular calculation. We have the probability of A or B on the left, and these other three probabilities on the right. We just plug them in and simplify it down. 0.7 plus 0.4 minus 0.3 is 0.8. And there you go. You can use this to solve for any of the 4 probabilities if you know the other 3. So in this situation, we want to find the probability of A, given the probability of B, A and B, and A or B. Well, write the rule, and then plug in the 3 things that you're given. 0.7 over here, probability of A is the unknown. 0.6 here for the probability of B. 0.15 for the probability of A and B. And then simplify things, and then subtract, and you get 0.25 for the probability of A. So it's like any formula. You can solve for any one of the variables in the formula if you have values for the other ones. In this situation, we have 4 things. If we know 3 of them, we can find the 4th. Okay, here's one more. Probability of A is 0.4, of B is 0.62, and of A or B is 0.81, and we want to find the probability of A and B. Well, to do that, you just write the formula, write the rule, plug in the 3 things that you're given, 0.81 over here, 0.4 and 0.62 here, and we're solving for the probability of A and B. Well, these two combine to make 1.02, and if you rearrange the equation, get the probability of A and B is 1.02 minus 0.81, which is 0.21. And there you go. Now you can try these two on your own and see how they work. Write the rule, plug in the 3 things that you're given, and then solve for the thing that you're not given. Okay? And you can pause your video now for however long this takes you, and then come back in, and I'll show you the answers in a sec. So pause your video now. Here are the answers. If you plug in these three given probabilities into the general addition rule and solve for the probability of B, you get 0.52. Okay, you can check your work. 0.72 plus 0.52 is 1.24. 1.24 minus 0.35 is 0.89. So it checks out. Okay, this other one, the probability of A and B is 0.14. You can check your work. 0.47 plus 0.32 is 0.79. 0.79 minus 0.14 is 0.65. So they check out. Okay, and you should always make sure that your answer checks out when you get finished with these. Okay, there's a little bit of trickiness involved because of the minus. You're subtracting off the probability of A and B, and that tends to cause problems. Always make sure that the probability that you get, whichever one you solve for, make sure that it's a positive number less than 1, or at least a non-negative number less than 1. Okay, it's going to have to be somewhere between 0 and 1 inclusive. All right, if it's out of those bounds, then there's a mistake somewhere, and it's up to you to go back and find it. Here's another example. We're going to expand on what we know about Venn diagrams in this example. Okay, we've got the probability of A is 0.5, probability of B is 0.3, probability of A and B is 0.15. Here's a Venn diagram that illustrates that situation. Okay, we have the A circle with a probability of 0.5, the B circle with a probability of 0.3, and the lens A and B has a probability of 0.15. Okay, I've marked the other three areas that we haven't been accounting for yet. This area right here, this part of the A circle that doesn't overlap with B, is the event A and not B. Everything in there is in A, and it's not in B. So that's what that event is called. This part that's kind of shaped like a partial moon, all right, out of that circle. Okay, there's a similar area over here in the circle for B. If you take the whole circle for B and subtract out this area that overlaps with A, you get this area, and it's called B and not A. And then outside the two circles, which form the union of A and B, we have the complement of the union of A or B. And another way to write that is as not A and not B. So there are two ways to write it, and I think this is probably the more common way that it is done. But it's important to remember that this and this are the same thing, and this area outside the circles is the complement of the union of A or B. Okay? Now we can find the probability of A or B by using our rule. Plug in the three probabilities that you were given. Get 0.65 for that probability. If you want the probability of this area out here, this event, subtract that from 1. Just use the complement rule and make that happen. Okay? 1 minus 0.65 is 0.35. Okay? If you want to find the probability of this partial moon shape, the probability of A and not B, subtract the probability of A minus the probability of A and B. 0.5 minus 0.15 is 0.35. And then if you want to find the probability of this moon shape, or partial moon shape, for the event B and not A, subtract the probability of B minus the probability of A and B. 0.3 minus 0.15 is 0.15. And there you go. You can try this on your own. Okay, well, look at these three probabilities. The probability of A is 0.49. Probability of B is 0.26. Probability of A and B is 0.12. And I want you to find these four things. Probability of A or B, probability of not A and not B, probability of A and not B, and the probability of B and not A. And you can pause your video and find those things, and then I'll show you the answers. So pause your video now, and then come back in a few seconds after you finish these things. Okay? You got it? All right, here we go. Probability of A or B is 0.63. 0.49 plus 0.26 minus 0.12. Probability of neither A nor B is 1 minus 0.63, that's 0.37. Probability of A and not B is 0.49 minus 0.12, 0.37. Probability of B and not A is 0.26 minus 0.12, 0.14. I hope that worked out for you.